I raised a question earlier, based on financial considerations, when should testing conclude? And as I said, there is an answer to this, and if you do the cost quality analysis that's shown in that article that I mentioned, you will be able to do this. Basically, what you have to do, and this is just economics 101 for those of you who took economics in college. You've got the marginal cost of finding a bug in test, which is the cost, taking into account all the factors that apply, of continuing testing until another bug is found. Now, the marginal cost of testing is going to go up as the cumulative defects found curve levels off, assuming a constant amount of test effort, right? So, you can think of it as kind of being that curve sort of in reverse. So when the bug find rate is low per hour of testing, the marginal cost of a bug in testing is high. The bug find rate is high in testing, the marginal cost of finding a bug in testing is low. Now, so then we have to say, okay, well, what is the average cost of a bug in production? And the way to look at that would just be, well, what's the total cost of external failure divided by the number of bugs which were found in production? And that's part of that cost of quality calculation. And from a purely economics perspective, what an economist would say is, when the marginal cost of a bug in testing, the cost to find the next bug, reaches the point where it is equal to the average cost of a bug in production, then testing should conclude. Now, this is an entirely financial / economic analysis. This does not take into account any moral, ethical, legal, or other considerations that might apply to your application. So, for God's sake, if you are testing safety-critical applications, please don't use this as your exit criterion. Oh, well, we've hit the economic saturation point of testing, so we're done. I mean, if you get software that can go out there and kill people, then obviously using this as one of your exit criteria is, I think the only word really is unconscionable. But if you're in other kinds of non-safety critical lines of work where really it does all come down to money, then certainly I would say that this should be one of the things that you look at. It does not make sense to continue to test to the point where finding bugs costs more than it would to just live with them in production or deal with them in production. In fact, you're actually, of course, you're paying twice, right? You're paying once for the money and once for the lost schedule time. So this is something that I think people should be able to answer, but unfortunately a lot of people can't. But now you can. Now you know how to do it. Oops. Okay, now there was another question that I brought up earlier, and I said there's four possible reasons, and some of you might have jotted down a few of those. Now you can check your list against mine here. So why do we need more information than just is shown on that open-close chart? Why is that chart with the red line and the green line not enough? Well, you don't know if the test effort was constant over time. So you don't actually know if the leveling off of the cumulative number of bugs reported, the red line on the top of that chart, if that is happening because testers are continuing to work but there are no further bugs to find, or if testers have been redeployed to other things, or they have been blocked, or what have you. You don't know if all the planned tests were run. So it could be that we got done finding bugs, but we had omitted some key tests, and so there's some holes in terms of our test plan. And if there isn't a good reason for that, then this is not a good situation. You don't know what risks were addressed and what risks weren't addressed. So you are not able, based on a simple open-close chart or found-fixed chart or reported resolved chart, whatever you call that convergence curve that I showed you earlier, just based on that, you do not know what risks were addressed and what risks were not. And so you don't know what your residual level of risk is. Similarly, you don't know what requirements and design specification elements were covered. So you don't know what level of confidence you should have in the system. And also, in a lot of cases, resolved is not only those bugs that were fixed and confirmed as fixed, but they can also, that resolve curve will often also include a deferral. And if the deferral rate has been extremely high, then really all we've done is sort of shunt this problem over into the field. So this is why we look for what I'm referring to here on the slide is balanced testing scorecard, where you report test status based on a collection of charts that balance each other out. And that will probably be the topic of a future webinar of you know, how to create a balanced testing scorecard, or at least give some examples of that, because that's clearly something that we think a lot of clients could use some help with. Okay, so I'm happy to turn it over for questions at this point. You've seen some of my favorite surprises, and I'd be happy to not just have questions, but any favorite surprises that you've had when you were working on a test team. And of course, if you're interested in more information about an assessment, including a quote, you can send us an email at info@rbcs-us.com. I'll put the advertisement up here as we go into the Q&A session. Let's see. So one of the questions is, Rex, this is via email. You often say that you should manage with data, and that's true. I've said that on many occasions. I think I said that here. However, what if the data you have is dirty in the sense that it contains information you know is bad? Can we still use it? Which is a great question. And the answer is, well, it depends on how bad it is and what exactly you're trying to do with it. So let's look at an example here. Now, let's say you're dealing with bug data, and you know that people who have been filing bug reports have chosen the priority value, and you file a bug report that has asked for severity and priority. And then people just have selected the priority value at random, or they always choose the first item on the pull-down list because they never had any guidance on how to classify bug priorities. Well, in a situation like that, obviously there is not a whole lot of value in trying to analyze that information. You're not going to get a lot of useful information out of that. And in fact, in such a situation, if you did try to analyze it, you'd actually get misinformation, misdirection. You'd be you pointed in the wrong direction with that data. Now, suppose though you're looking at analyzing the bug closure period, which is the time from discovery of a bug to its ultimate resolution. And suppose most of the testers enter bug reports on the same day they find them, and that most of the testers perform the confirmation test the same day they receive the bug fixes in a build. So, if just a few bug reports are filed a day or two late, and some bug fixes are not retested until 2 or 3 days later, you still use the closure period metric. It's still going to be a meaningful metric. The only question is, is it clean enough, basically, clean enough for what you're going to try to do with it? And I think that's a good question to ask, because certainly you don't want to use data where data is going to point you in the wrong direction. Okay, so we have a question here from Samaya. Can you please elaborate more on specific circumstances where blending works out to be counterproductive? Okay, that is a good question, because I said that sometimes you want to blend, most of the time you want to blend, and but sometimes you don't. So let's see. Well, let me go back to the example that I gave, where I said that we had recently done a project where it was purely exploratory testing. So